All right, I'm Thomas Hintz. I work at Franz. We have a number of common Lisp products as well as the Allegro Common Lisp compiler. So I was just going to talk about how we manage shared memory in AllegroGraph, which is a triple store graph database that I work on. It's somewhat interesting. So we have a number of processes that run for the database, and they need to share memory. I don't know if you've ever done shared memory stuff before, but it can be complicated. You have to share file descriptors and somehow communicate between processes, like the file descriptors to use. So we have a server that runs as a separate process that will handle creating, attaching, and detaching your shared memory segments. So there are a number of issues with shared memory that you have to deal with. Like I said, the management. The shared memory is kernel level persistent. So if you're not careful to unlink it, it will stay around even after your process dies until you reboot the machine. So we don't want that. It only has a single namespace. Internally, we simulate multiple namespaces, so you don't have that issue. And Linux will say you have some shared memory even if it doesn't have it or won't have it eventually. So it kind of lies to you, so we have to deal with that as well. So the server, when it gets a request to allocate some shared memory, it first allocates it, then unlinks it before returning the file descriptor. This ensures that if anything happens to the database, the memory gets unlinked and it's not mapped for the rest of the time your server is running. One of the fun things is we have Lisp, and so we can just use read and write for sending commands over a socket between the client and the server. You don't have to use JSON or SOAP or anything extra fun like that. In this case, you can see we want to create a shared memory segment. So the top block is the client, sends a list, writes out a list with the command create, then some parameters like the name and size. The server is the second block. It just reads that from a socket, pops off the command from that list, and dispatches based on that command. And the rest of your list can just be arguments into whatever function you want to call. There's also the issue I mentioned with it saying you have memory even if it might not have it eventually. All it actually cares about are the pages that you use. So Allegro Common Lisp gives us access to the POSIX interface as well as some low-level pointer manipulation. So what we actually do is get the page sizes and the start of the shared memory segment, and then go through each page and what we've allocated, touching it, so that the kernel doesn't give away our memory. In the end, it's just one part of the full database, which we can. It's a quick demo, just run a query on it. And you can get cool graphs. In this case, it's just showing links between medical conditions. Basically, calculates some odds ratios. And let's say you have an open wound of fingers without mention of complications. You might also then have other specified vaccinations. So basically it says there's a higher probability than normal that these conditions are linked. This is just fabricated data, that's why the names are so awesome. But this is just one of the many things you can do with it. So yeah, that's one of the fun things we get to do. If you're ever looking to hack on Common Lisp or work on low level to really high level Common Lisp stuff, we're always looking for people. So can send me an email, thintz@franz.com, or talk to me afterwards.
So I'm going to interject before the questions come. We actually were hosted by Franz last year, and it was a great pair of talks, which we have on YouTube now. If you go to balisp.org/videos, you'll see them about sort of the overarching framework that all of this is inside. Yeah, including a lot more time for demos.
Yeah.
So now.
What is this useful? Is it general Linux facility?
What?
Is shared memory general Linux thing or?
Yeah. Just general Linux shared memory.
Yeah. You talk about the database. What is the specific database?
It's a triple store graph database.
Oh, okay.
Yeah, so a specific kind of graph database. It's based on a triple standard that you can.
Or something, or?
Yeah. Yep.
Do you do a smart goals type thing?
Yeah, that was what we were looking at. Yeah. So sort of RDF and related is sort of like a more structured web. So you can, as we see here, these are like the table of the results, their URLs. So it's more freeform than like a relational database, but more standardized. So you can communicate with other companies, other general databases. You can go online, download, and query RDF databases. Any other questions?
What's so special about this does all kinds of really cool things based on a data structure with 2 plots.
Yeah.
And apparently you gain something by extending out to a data structure with 3 slots, a relation and a subject of object or something like that.
Yeah.
What if you get a similar game if you go to 4 or 5? Is 3 some kind of local maximum in the slot performance ratio of data structures? What's responsible?
It's not really related to a data structure in this case. There's a subject and a predicate and an object when you're running queries, and so that's why it's 3. There's actually a 4th one, which is kind of a way to do name spacing, but generally it's called the triple store. It's kind of not related to anything else. But, yeah.
Why not a quadruple store?
I mean, I don't know. I didn't invent any of the specifications. I just work on it. You'll have to ask Tim Berners-Lee. He worked on it a lot. You could ask him maybe.
It's almost like identity of the object, and then there's the name of the property of the value corresponding to the object. That's SQL way of seeing it. Because there's a lot of IDs involved, right?
Yeah.
Those things are not data, they're just ID thinking about
Uh,
It's amazing point that you can build the evidence from it.
Subject to the shared memory.
Yep.
So you're going to serve your hands off shared memory?
What was that?
Your server hands off in reference to the shared memory? And
Correct.
the library uses it in reference to the
Yeah, so there's multiple processes, and they might want to access that shared memory. So the shared memory server just says, all right, I've allocated it, here's a file descriptor. And if multiple processes want to access the same shared memory, they use the same name. Like when we looked at that create command, the name will be the same, and it'll return the same file descriptor, so they can read and write the same memory. Does that answer your question? Yeah. Any other questions?